Hello, family. Good morning. It's time for Newton's law of motions. Form 5. Uh, Newton's those laws of motion. Uh, so, this is subtopic number 1, by the way, in mechanics. So, speaking about the Newton's law of motion for Form 5, we're just going to discuss about 3 objectives. The first thing that you need to discuss here is about the laws. So, you need to know about the laws. Uh, This is number 1 in mechanics. So you need to know things to discuss here. It's about the laws. Laws. The second thing that you need to understand here is all about the motion of connected bodies. Motion of connected bodies. Bodies. So simple. And number 3 is all about the conservation of energy and conservation of momentum. So the laws actually of conservation cases. You discuss them. You just discuss about the collision when you were in Form 2. In Newton's law of motion. But here you're just going to discuss about 7 to 8 cases about the collision, about the recoil velocity, the rocket propulsion, the jet propulsion. You're just going to discuss about ballistic pendulum. So you're just going to discuss a lot of things, just conserving about the conservation of energy, and momentum, and the law of conservation of momentum. So let's start with part 1, just about the law. Let's speak about the laws. Let's revise about the laws. Here, basically in Form 5, we'll just be asking most of the questions. It's all about the examples, the daily examples of the laws. The daily examples of the third law, second law, the first law, which you learned, by the way, in Form 1. So you need to have as much as possible examples here. So in laws, this is objective number 1 for the Form 5s. Let's discuss about the law. Let's revise something here about the laws. So this is part 1. Part A is all about the laws. Let's speak about the laws. There is the first law, there is the second law, and there is the third law. That's cool. So state about the first law. The first law states the moment of what's the fact? So the first law states that a body in motion or at rest will remain so unless acted upon by the external force. So just remind you, you know about that. So it's called the law of inertia. Law of inertia. Inertia, the first law. And what is inertia, by the way, is the resistance to change the state of the body, either in motion, to change the state of motion, or to change the state of rest, or to change the direction of the motion. So there are 3 types, by the way, of inertia. 3 types. Type C. You need to know about the types of inertia, which are inertia of rest, inertia of motion, inertia of direction. So before we discuss about the real examples, the daily examples of the law of inertia, so you need to know about the types of inertia. So the resistance to change the state of rest, that's called the inertia of rest. The resistance to change the state of motion is called the inertia of motion. And the resistance to change the direction of the motion is called the inertia of direction. So can you give the examples of inertia of rest? So you need to have a lot of examples, by the way. So inertia of rest, one of the examples is removing the dust from the carpet. So if you have a centennial carpet, you're having some dust, and you want to remove the dust from the carpet, by the way, you just beat up the carpet. Let me take an example here. For example, if this is the exercise book here, having some dust. If I want to remove this dust, I just force the exercise book to move as fast as possible so as the dust will remain at rest and fall down. For example, do you see that? So as I have pushed it, I've beaten the exercise book so that the dust tends to remain as I set it fast in motion. So the dust falls down because they tend to resist the change So it's called the inertia of rest. So the dust due to inertia of rest are removed from that exercise book. Let's pick up, so removing the dust, removing dust. Example number one, daily examples. You need to know about that. Dust from the carpet, carpet, by beating it, beating it. That's the first thing. The second thing that you need to know is about, let's say, mud. Mud flies tangentially. When a fast wheel, when the wheel is rotating very fast, when a car is passing across and has attached some mud, when the wheel rotates as fast as possible, mud will just fly tangentially. So flying tangentially, flying tangentially, mud, let's say, with the mud flies tangentially. Mud, let's speak about mud flies tangentially. Charlie, from the wheel. When the wheel is fast moving forward, so when the wheel is rotated so fast, so if this is the wheel now, and it has just rotated very fastly, then mud tend to fly tangentially. Even the same thing, that's we call the inertia of direction, meaning mud from the tile resists to go in the direction of the wheel. That's what happens. The mud flies tangentially, meaning has resisted to come in the direction of the wheel. The same thing when sharpening a knife using a gliding wheel. So when sharpening the knife, those we call sparks flies tangentially. Why sparks flies tangentially? It's because they resist to go in the direction of the gliding wheel. So sharpening of the number three, another example of the image of direction is sparks. Sparks flies tangentially from the gliding wheel. The gliding wheel from the gliding wheel. When sharpening a knife. That's all about that. Another thing is when you pull. It's when you pull, and let's say you have a stone here, and they are pressed on the table. When you pull as fast as possible an exercise book, the stone will just remain on the table without being moved. But if you pull it so slow, the stone will move on the exercise book. So we just say when a paper or a book is pulled as fast as possible, the stone above the book will just remain on the table. Why? It's because the stone has resisted the change. So we call the inertia of rest. Has resisted to change the state of rest. Okay, another case, let's say removing. Number four. When a book is pulled so fast. A stone above it, a stone above it remains on the table. The reason is why the stone has resisted the changes. Another example, if we measure when a car starts, I just remind you, when a car just starts abruptly, a passenger falls backward. And when it stops abruptly, a passenger falls forward. Those are the examples. Let's shift to the second law. Let's shift to the Newton's second law. Newton's second law of motion. Let's speak about the Newton's second law of motion. Newton's second law of motion. Okay. So speaking about the Newton's second law of motion, second law of motion, it says the rate change of momentum is then proportional to the force. And always, the change in momentum is toward the direction of the force. So, the rate change of momentum, the change in momentum, when I put D in the differential, is that proportional to the force applied and goes to the direction of force. So speaking about this, what is the momentum? Momentum, we know, is the product of mass and velocity. By the way, the rate change of momentum, meaning we have the initial velocity and the final velocity. So talking about the change in momentum, meaning we have the mass and we have the final minus the initial. That's what we can say the change. So speaking about the change, we can just say the force, removing the proportionality, which is actually equal to 1, is just equal to mv minus u over who? Over time. The change in time. That's what it's speaking about. But talking about the change in velocity per time, that's what you say acceleration. So m is just equal to ma. The force is just equal to ma. That's about the second Newton's law of motion. There is something that you need to know here. Something you need to know here. Not this here. There is something we call impulse. Impulse. So the second law expresses about the impulse momentum theorem. Impulse momentum theorem. The second law speaks about the impulse momentum theorem, which is, we say, force times dt. That is just equal to the change in momentum. So what this is the impulse. What is the impulse? It's the product of force and the time taken to give a certain change in momentum. Hey, gets me clear. Speaking about the impulse, it's just equal to the rate change. It's just equal to the change in momentum. So this is called the impulse. Second law results into impulse momentum theorem. What is this theory talking about? The theory states that whenever you want to use a short time, you need to use the maximum force. And whenever you want to use long time, just use a small force. So it states actually, it's the result of this one. So we say, whenever you want to give a certain change in momentum, actually, force is inversely proportional to time. For specific, this momentum should be constant. So whenever you want to produce a given momentum, actually, the force is inversely proportional to time. So F is inversely proportional to time. This is very important. So it states actually, for a given change in momentum, the force, a small force is applied for long time. And actually, you need to know a large, large force is applied for a short period of time. That's what we speak about the impulse momentum theorem. What are the leading examples of the second Newton's law of motion are actually the use of the impulse momentum theorem. Let's discuss about these examples. The first thing, a goalkeeper stretches the hands so as to increase the impactive time in order to reduce that force by which the balls come in contact with him. So a goalkeeper tends to stretch his hand to catch the ball in order to reduce the impactive force on his hand, because he has increased the time. So in order to reduce the impactive force, you need to increase the time. Now he catches in front, and as it comes, the time increases the time of collision. You call the impactive time. So a goalkeeper stretches the ends. That's one of the examples. Let's speak about these examples of the second law. Yeah, really life examples, daily examples. Yeah, a goalkeeper, a goalkeeper, goalkeeper, keeper, stretching, 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 hands, hands, hands on catching, 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 catching the ball, the ball, the ball. Why? To reduce the impactive force, to reduce the impactive force, to reduce the impactive force, impactive force. Let's speak about number 2. It's easy and comfortable to sleep just on the mattress or on sand than on a concrete surface. If you sleep on the floor, on the concrete surface like this one, after a time you just feel pains because this one doesn't allow the impactive time. It doesn't squeeze, but the mattress like this, when you sleep here, it just squeezes, so it increases the impactive time for you to collide. Because talking about the collision is you coming into contact with something. So two objects when it comes in contact, as we say, the collision. So speaking actually about a person sleeping on the mattress, you feel comfortable than a person on the concrete surface. Why? Because the mattress allows the squeezing. They increase the time for collision. So we say actually sleeping on mattress. Mattress is more comfortable than on concrete surface. Okay, number 3. Let's say about want to speak about the second law. A person even jumping from high jumps, he always squeezes his legs. Why? To increase the impactive time. You can't jump from high jump and then you stand without squeezing your legs. It's because your downward limbs, because you just feel pains. You have the maximum force. But the person jumping from the high jumps, he squeezes his legs or the lower limbs because he wants to increase the impactive time so as to reduce the impactive force. So actually, a person bends his leg. An athlete bends the lower limbs. Yeah. When jumping, a high jump. Why? To increase the impactive time, so as to reduce the impactive force. Those are the things that you need to know. Even why warehouses? Where material, for example, TV, phones, are always in a box that contains a sponge. This is because when they are transported from China, from Dubai to come here, during shipping there are some collisions in the process of transportation. So if they have a sponge like this, will just increase the impactive time so as to reduce the impactive force on the device so that it may not be destroyed. Because when a phone is now kicked with a high force, that means it is destructed. But when it is transported while in a sponge within its box, meaning it will just, that force will just be absorbed with that sponge. Why? Because it tends to squeeze to increase the impactive force during the time of collision. So the wear material, for example, televisions transported or electronic material are just transported from China. They are covered with boxes or with the sponges. Why? Goods like TV, are covered with spongy. avoid destruction during their shipping. Those are things you need to know. Okay, how about the third law? Let's discuss about the third law. Let's discuss. Let me remind you about the third law. Form 5. You learned about this. That for every action, there is equal and opposite reaction. This means the body, this means whenever there is a force, there must be a reaction. But the reaction is opposite to the action, which is now the force. There is one famous question that they tend to ask much. If the action and the reaction are in opposite direction, why do they not cancel each other? Actually, for the action and the reaction, they occur in different bodies. For example, if I push this hand on the board is the one exerting the opposite. So actually, they do not act on the same body. If they could act on the same body, now they could cancel each other. But if they are, if they are acting on different bodies, they can't cancel each other. So they don't cancel each other, action and reaction, because they are from different bodies. For examples now. One, walking on the ground, walking on ground. So a person actually walking on the ground, he pushes back the muscles. So the muscles pushes back while the ground pushes forward. So he is able to walk on the ground because he pushes back and the ground exerts the forward force. So that is the reaction. A person swimming pushes back water while water exerts the forward force. So swimming is one of the examples that are low. The other thing, the third thing, rocket propulsion. We'll learn about this and you will calculate about this for 4 points. Rocket propulsion. Let's discuss about rocket propulsion. What's about the rocket propulsion? Rocket propulsion is now the process of taking the rocket from the ground now to the atmosphere, to the universe, so as to observe some scientific analysis. So speak about the rocket propulsion. How is being propelled is the rocket tends to the fuel within the rocket tends to burn so as to create the maximum pressure, and the gas is now released. When the gas is released abruptly, it exerts the action. It exerts the force on the ground. So the rocket gains the reaction, which is the force opposite to that of the direction of the gases. So the rocket tends to go up because it has just released the burnt gases, we call the exhaust gases. So this one is one of the applications of the third law. The fourth thing, even a bird is a bird flying on air. It's because of the third law, because it pushes the air and then it gets an upward force. So we say, flying of the bird, flying of the bird. Okay, class. Those are the daily examples, and there are so many. Go just and look on that book of mine, or in Chandi, or where in the compressive physics. You just get a lot of examples about this. So on Form 5, about the laws, you need to know about the daily examples. You need to know them and why are they done. Okay? Garden, I'm sending out. So the part 2 will this is part 1 for the needles, is all about the laws. The part 2 will just be about the motion of connected bodies. I think the new part, don't miss it. And the third one will be about the conservation of energy and the conservation of momentum. I'll just drive about the 7 cases that no teacher in this country or outside will teach you about this. It's only Mr. Kusema. God damn it, I'm signing out.